Popcorn?
Yeah.
Okay. So part of the reason that I had to do that lab yesterday was just to kind of begin to get a feel for the difficulty in measuring things that have charge. Okay? Because it was like, is it positive or negative? I don't know. Does it repel? Does it attract? I don't know. It becomes attracted to my hand. Is my hand positive? Is my hand negative? Is my hand neutral? Okay? And then you also run into the problem with, oh, the electrons are going to fade out over a period of time and everything's going to reestablish charge. And then what do you establish as the baseline? What's positive, what's negative? So one of the things that you can do is that you have this handy dandy little device. And what this does is that it measures the field, whether it's positive or negative. And it also measures the intensity of the field. So I'm going to take this balloon. So we'll use the balloon to establish what's positive and what's negative. So rub the balloon, and then we'll turn this on and reset it. Boom. So I take this and I bring that balloon close to it. So there's a couple of things that you'll notice. Number one, it's going into the negative region, right? Right? So the other thing that happens is that this is a function of distance. Because so that electric field, K, Q1 over distance, because there's an inverse relationship there. So when I bring this close, that maximizes that out. And I take that away, hey, it goes back to being neutral. So there's a limit to what that can detect. But it shows you two things. Number one, we've established the baseline. Hey, this is a negative charge. But here's the problem. If you take a piece of tape, this is the frustration. If you take a piece of tape and it attracts to the balloon, does that necessarily mean the balloon that the tape is positively charged?
No.
No, it could be
Neutral.
It could be neutral. But you're just driving those away. So that's the beauty of a device like this, is that it quantifies that. Hey, is it positive or is it negative? Now, you get into, and this is going to be part of your assignment today.
Gavin. What the flip, dude?
Come on, Gavin.
Yeah, it wasn't
So
even
I'm
Gavin.
actually over here.
Natural reaction, I understand.
That's a Gavin special.
So, quick review. What type of mirror?
Convex.
Convex.
Convex, right? Okay. No matter what I do, I see myself right side up and small. So, let's say, for example, somebody. Okay. So, when you get into how you charge items, there's kind of two different thoughts. So, if I take this balloon, which we just established as being negatively charged, and let me kind of charge this a little bit, and I bring it close to this conducting sphere. This is negatively charged. This is conducting, meaning that the chihuahuas can move around. So if I bring this close to it, what's going to happen to the chihuahuas? They're going to go around to this side, right? And this is going to end up being with a net positive charge. Now, if I test this, okay, hold on.
Is that called the ground? How does that work?
Basically, it gives the electrons, the excess electrons, a place to flow so it doesn't build up on the machine itself. Okay. So, I bring this close, okay, and you'll notice that when I bring that balloon close, that is shifting into that negative region. So the reason that's happening is that these chihuahuas here, this electric field, is influencing this electric field here, and it's driving those chihuahuas over here, and that's why this side is going to be negative, this side is going to be positive. Now, if I take the balloon away, then what's going to happen?
Back to normal.
Back to normal. Okay? It's going to be back to normal. Now, here's the difference, though. If I take this negatively charged balloon and I actually touch this, then what's going to happen to the charge on that sphere? It's going to be negative. Why?
Because it transfers over.
Transfers.
So now we're trying to balance this charge out. So Mother Nature likes to balance things out. So if I actually touch it to it, that becomes one system, and the electrons are going to share it out over this whole thing. So that's permanently negatively charged. If I just bring it close, it's temporarily positively negatively charged, but as soon as I take it away, it goes back to being neutral. Big Mike.
So that's a conductor because like the electrons gonna move around, right?
Yes.
So then, so is it insulated like the electrons like can't move around freely?
They can, but just not nearly as freely. Okay, so this is why in a problem like this, it's always done with like a conducting sphere. Now, let's do this. I'm going to take these two, and I'm going to connect it by a conducting piece of metal. Okay, all right? So, I'm going to charge this up again. Okay? Now, this is important in terms of the sequence. If I bring this close, what's going to be the charge on the sphere closest?
Wait, negative. Closest.
Negative.
Negative.
I'm not touching it. I'm just bringing it close. This is negatively charged.
Positive.
So this sphere is going to become
Positive.
why?
On that side, electrons flying away.
Because all those chihuahuas are going to move over here.
Yeah.
So if I bring this close, I'm not touching it. This is going to be important. I'm not touching it. If I bring this close, because this gives the chihuahuas a path. Okay? They can move. It gives them like a dog run in between the 2 yards. So if I bring this becomes positively charged. That becomes negatively charged. Now, visualize this. I brought this close. Positive, negative. Now, if I separate it, and move it away, now what's going to happen?
Now everything's
This one's still positively charged
And the other one's negative.
because the electrons can't go. So we shipped the chihuahuas over,
Check it.
but then we took away, hold on, but then we took away the bridge or the dog run, and the chihuahuas can't come back. Okay?
So air can't act as a conductor.
No, air is a horrible conductor, and that's okay. Because if air was a good conductor for electricity, every time we had a lightning storm,
We died.
yeah, bad things would happen. Right? It's okay that air is an insulator.
Okay.
We don't have a problem with that. Now, in contrast to that,
Oh, now it's on it.
okay,
Back
that's
to,
that. Put it all back.
back to equilibrium.
Now, if I charge the balloon again,
I didn't even fly over.
and if I touch it,
Negative
then what's going to happen?
You're
giving electrons Negative.
Is everything going to be negatively
Yes,
charged?
because they're touching.
But it's going to have less negative charge than if I just touch.
Right.
Why? Because
Because
the
it's
spread
distributed
got out
circuit
over a larger area.
Right.
Okay? So this is literally what they did to create positive and negatively charged particles, spheres. They had these conducting spheres. So if you want them permanently negatively charged, and you have 2 of them, and you want them to have the same negative charge, okay? Take something that's negatively charged, touch it to it, and they're both going to have the same negative charge.
Right.
Okay? But if you want to create positive and negative charges, and this is important in terms of the sequence. So you have a negatively charged or positively charged, it doesn't make any difference. Let's say we're going to take a negatively charged balloon, and we're going to bring it close to it. Okay, we're going to bring it close to it.
One is positive, one is negative.
This is positive, that one's
Negative.
Negative.
Now, but if I take it away, before I take away the bridge, what's going to happen?
Neutral.
Everything's going to be back to being neutral. So I've got to bring this close,
Take off the bridge.
hold it here, take away the bridge,
Positive, negative.
then I take away the balloon.
Now, did
Then
your
I've got a
skin-
negative, and then I've got a,
Did your
Positive.
skin take any of them or no?
huh?
Did your skin act as a bridge and take any?
Maybe just a small
But
amount.
not.
Like 1 or 2,
Yeah.
maybe.
1 or 2.
Maybe 5.
Maybe 6.
All right, it's not going to happen again. I know my formulas.
Okay, that's good to hear. Okay, got the visual, good, Brand, back we go.
What about that?